Yeah, I don't know what's going on here. This didn't show up very well. So this is a position graph. I hate x as a variable. It's confusing because we have x on the y-axis. What the hell? So position. Does it say meters on your thing? Yeah. Okay. So I'm gonna throw a unit there. Meters. Then this is time in seconds. And then this one clearly is velocity. And we'll guess meters per second for that. This is time in seconds. All right. Dots are every 1 second. The first dot is located at 2 meters. So 1, 2, 3, 4, 5, 6. All right. So I'm going to put my first dot at 2 meters. 2, 3, 4, 5, 6. Where's the next dot at? 4 meters?
Yeah.
Okay. And that's going to happen at 1 second. Okay. And then the last dot is at 6 meters? No.
There's one at 6 and one at 8.
Oh, crap. So I'm going to have to renumber my graph now. I'm not going to have to renumber my graph?
No, I was asking because it mattered where you put the on which axis you put.
Yeah.
Because I put seconds on the x-axis.
I would not do that. Okay, so that's problematic. Seconds should be on the horizontal axis, and the position should be on the vertical. Yep.
Yeah, that's what I have.
Good. Then you're fine. All right. So time 0, we're at 2. At time 1, we're at 4. At time 2, we're at 6. Time 3, we're at 8. Okay. So again, when you have a data set given to you like this, you don't need to like avoid all the lines. Okay. So go ahead and draw the line that connects all this business. Looks something like that. And just kind of by habit, try to like be always thinking about the slope of a line. So what is the slope here? And again, when you're calculating the slope here, because they're given data points, you can use data points in your slope calculation. So I can say 8 meters minus 2 meters equals, over 3 seconds minus 0 seconds. And that's going to be 6 meters over 3 seconds. And I don't like fractions, so just kind of know that about me. I also don't like Chromebooks up when we're not doing Pear Deck or Chromebooky things. So,
I was hoping it should there.
ain't gonna happen. I gotta walk over there. I can just flick. All right. I don't like fractions. 6 over 3, that's 2 meters for every second, which should kind of sound familiar because we were moving it 2 meters every second. Okay. Write a mathematical expression for the relationship between position and time. All right. That's a line. That's a linear graph. It's going to be of the form y equals mx plus b. I don't like y equals mx plus b. It's too vague. What's on the y? That's position. M, we just figured that out. That's 2 meters per second times the thing on the x-axis is time. See, like I don't like calling it the x-axis because there's x. Plus, looks like it touches at 2 meters. Okay, so that's a mathematical expression for that. Then when I want to go and graph velocity, this would be 0. This would be -1, -2, -3, 1, 2, 3. And I got to plot the velocity. Well, I talked about this, I think, a little bit yesterday, maybe, that the velocity time graphs in this unit, constant velocity particle model, they should be horizontal lines. The slope on my position graph is not changing. It looks the same the whole time. And it is 2 meters per second. So I'm just going to plot this across 2 meters per second. Okay? Write a mathematical expression that represents the relationship between velocity and time. What is the velocity? Ooh, I didn't put the time on here yet. Let's do that. 1, 2, 3, 4, 5, 6. Hey, Kiana, what's the velocity at 1 second? Two meters per second. Okay. Hey, Grace, what's the velocity at 2 seconds? What's the velocity at 2 seconds? Hey, Maddie, what's the velocity at 3 seconds? Hey, Teo, what's the velocity at 4 seconds? Hey, Awesome, what's the velocity at 8 seconds? Probably would be 2, okay? So, in other words, at whatever time I ask you, the velocity is going to be equal to 2 meters per second. It doesn't change with time. So that's how you would write that mathematical expression. All right. The bottom part, we got to do some editing here because a math teacher wrote this, and, well, hey, they've got a lot going on in their lives, and so let's not throw stones. We're going to crosshatch. Well, this isn't the 1800s, so let's just call it shade in the area. I don't like under, because immediately if you shade under, you're going to shade all this, right? That's the area under. I don't want under. So let's get rid of under. That's a bad word. Let's say between the velocity time graph and horizontal axis. That's a lot of words, but so now what I'm going to do is I'm going to come up here and I'm only shading, easy now, horsey. Because it was dumb before. Because if you did what it said, that would be the wrong thing to do. Math teachers. All right, so we only want to shade the area that is between the graph and the horizontal axis. Between is a really important word for reasons we'll see here in a second. All right, now it wants the units of the area. Area of a graph. Who's done area of a graph before? Area of a graph? 2 people? Great, okay. Hey, birthday girl, what shape is that I just shaded in there? It's a rectangle. How many people have calculated the area of a rectangle before? Jesus. You have not calculated the area of a rectangle, Roberto, ever in a math class? You're just not raising your hand because you're like, it's cold. I'm going to keep my hands warm. All right, fair enough. So this is going to be one of the most commonly used equations this year in physics. Area equals base times height. All right, so look at what you just shaded in. And what is the base of this thing? 6 seconds or meters? Seconds. All right. What is the height of this rectangle? 2 meters per second. All right, so what is the area of this rectangle? 12 meters per second? 12 meters per second squared. What is it? Run it by your neighbor really quick. Do the same thing to the units that you did to the numbers. All right, run that by your neighbor. Does that cancel or does that not cancel? If I took 4/1 times, hey, if I took 4/1 times 8/4, what is that going to be? It's 8/1. Okay, those are going to cancel. So those are going to cancel. So I've got meters over 1, but nobody but math teachers writes meters over 1. That's goofy. All right. How many people are confused? How many people don't want to admit that they're confused, but are maybe confused? Okay, maybe a few. Okay, so we just calculated an area, and we got 12 meters. What's weird about that? Usually when you calculate an area, what is it? Something squared. Inches squared, feet squared, miles squared. We just got meters. That's weird, okay? But step aside from this for a second, and can you understand that if you go 2 meters every second or 6 seconds, how far you go? 2 meters, 4 meters, 6 meters, 8 meters, 10 meters, 12 meters. Okay, we go 2 meters every second. So what I'm trying to share with you here is just a visual way of solving for that with the velocity versus time graph. Effectively, we've taken time and multiplied by the velocity to get what? What is 12 meters to this? It's the displacement. Thank you. Okay. So displacement equals base, which is time, times the height, which is the velocity, or we should maybe say the constant velocity. All right. So that's kind of like an equation or something. But in effect, you're just finding the area of a rectangle. Hey, spoiler alert, not always going to be a rectangle. Sometimes going to be maybe a triangle, maybe a trapezoid. Whoa. Okay. So that's why we had to learn that formula. Don't worry, we're not there yet. That's months down the road. All right. Describe the area under the velocity versus time graph represents. What does it represent? Displacement. Yes. Okay. Yep. And we got the value to be 12 meters. So what's our evidence that it is the displacement? What about that answer of 6 seconds times 2 meters per second? What about the answer we get from that tells you that it has something to do with displacement? Second times velocity, but then your answer's got what for the units? It's meters, right? So that's kind of your evidence. Like, okay, area between, buddy, this is an important word choice. Between graph and, can I call it the x-axis? I should probably call it the horizontal axis. Displacement. Units of area Gesundheit are meters. Oop, I forgot to put my answer. 12 meters. It's the number value. Okay. What else is going on this sheet? Oh, yeah. We ought to hit that up. Okay. Let me talk to you about a couple of things here. Okay. I want to remind you of the specific definitions of a couple of words. Displacement and distance. Check with your neighbor really quick and see if they can distinguish those words for you. What is distance and how is it different from displacement? Sitting by somebody that's paying attention? Oh.
Me too. And then we bought coffee. Same. Didn't you say far too much? Imagine having that.
Hey, let's pop back over onto the Pear Deck. Now that I told you to shut your Chromebook, I'm going to tell you to open your Chromebook.
I'm really so freaking
Hey, cow. Eventually, is it class over?
No.
Okay, thank you. Yeah, let's do that. Hey, go ahead and pass your quizzes over to the Kiana end of the room.
Can I show you how good my slides are? They're actually this one's pretty good. But like compared to what these are good slides. And yeah, Haja, she's in my perfect class. And we have random partners and me and her just randomly good. Like, look how ugly these slides are. Like I'm clear, but like I don't know.
Hey, did we do these yesterday? I can't see your answers yet. We did this one? Did we do this one? No, we didn't. Did we? I don't see anything.
Regression analysis assist.
You got an answer on your screen right now, though? Then you did it. So it's just not getting there. Come on, catch up.
Really don't know.
Let's see. 24. All right. We got this, friends. Paradox says, seriously, this should be done soon. Did you? No. Nope. Drew did it. Amir did it. The rest of you need to join us.
Yeah, I could. I think I have like a 4-page
Oh, that does my heart good. I'm seeing people putting vertical lines in there to separate the sections of the graphs. You like me. You really like me. Dang, kids, you're not bad at this.
Oh, same. Look at how many can be all of it. Like how many there are. It's like it's overwhelming. This? Yeah. We have to make a decision.
Page.
Pick up like that from his.
Oh boy.
What the heck? I don't know. I know, saying because like that would be the first. It's supposed to be not as steep as the first one. But like that should be that. Yeah, that's what I thought. That is not that. You know how we made those 3 lines over there? So what is supposed to? That would mean it was just straight like this. Oh, I think it's probably like this.
So what you've got going on is kind of a good pre-quiz for tomorrow. What types of things should you expect? We already had 2.1 on that first quiz that we just took. Given a position graph, can you sketch? Ooh, we didn't have this before, but now you will. Given a position graph, can you sketch a velocity graph? Can you sketch a motion map? Can you describe the motion? Given a position graph, can you find the velocity? What is velocity? Okay. Average velocity and average speed. We're going to talk about that in a second. Velocity graph. How do you find the displacement? We just learned this. How do you find it? Yep. It's the. Yeah. She said between. It's the area between the graph and the x-axis. Okay. Velocity graph analysis. Given a velocity graph, can you sketch a position graph? That's what I'm asking you to do right now. Motion map, motion in words. Given a motion map, can you sketch the velocity graph? Position graph, graph motion in words. Word problems. And then this last thing that we're talking about right now, distance versus displacement. Can you distinguish the difference between distance and displacement? Calculate both on a graph? Hopefully. All right, let's see what's happening over here. Ooh. Ah, man. Okay. It's looking fairly uniform. There's like one key difference. So let me shut you down for a second. Hey, chill. Okay. So take a gander at these two things. And all right. So take a look at these and have a conversation with your neighbor. Okay.
Yeah. There's it, right? Yep. And you put the lines in it.
And I'm going to give you a clue about something here. As soon as I get that there. All right. Boop. Now this is a new thing we're talking about, so I don't know that this is real fair to throw at everybody, but I'm going to do it anyways because I'm a teacher, which means I don't have feelings. All right. See these graphs? What? Oh. Hey, friends. Versus, this is the part about between, right? Not below. I'm going between the graph and the x-axis. Okay? Look at that. And look at these two answers. And have a little conversation with your neighbor. Based on what I'm showing you here in terms of rectangles, boop, boop. All right. So let's see if you're picking up on the.
You're so close.
Chill. Dig my Mondrian, right? Yeah, kind of, a little bit. Elementary art school fans. So, looking at these two rectangles, what does that tell you about the displacement from beginning to end that we should see on the position versus time graph? Because if you look at this one starts here and it ends up here. What would be true of the displacement here? Positive, negative, or zero? Initial position, final position.
Positive.
That's a positive displacement. Initial position, final position. Negative displacement. So look at those rectangles. Have a little chat about it over on the pair deck. Based on what you see with those rectangles, what does that tell you about displacement?
So that
All right, and then once you, looks like we need some more folks to have a think about it, maybe. Ooh, that's loud.
Great.
Okay, I'm not clear on what I'm seeing on the pair deck that you're picking up what I'm putting down. Let me ask this differently. Hey, A or B? Based on what you're seeing here, who's got better evidence to support their position time graph? All right, that's not great. No, it's getting better. So right now we're looking at 16 to 4. Okay, 16 to 4 here for A. 17 to 4 for A. Okay. And what's up with that? I'm not seeing it over on the answers in the pair deck. Okay. Basically, what I'm trying to get at here is yellow area is bigger. Okay. The area between the graph and the axis that's yellow is bigger. So greater displacement for that part. or however we want to say that. Yellow area is bigger, so greater displacement for that part of motion. Okay, and then this is a little bit smaller at the end. So there's a smaller negative displacement at the end. Okay. Can I click on those and drag them? Can I overlap them? Oh my gosh, look at this. See it? Whoa. Yellow and blue make green. Now I can't grab it and move it. Okay, so hey, do you see what I did? I took the purple area from here. Hey, I'm sliding it over for comparison. So the total displacement would be the yellow minus the purple. So basically the yellow that you see remaining would be the total displacement. It's positive. Okay, so I'm not using numbers at all to compare. I'm just visually representing the displacement by the shaded area there. Okay, this is sort of one of the two really big ideas from this unit. Okay, you want to sum this up in two sentences. Velocity is the slope on a position versus time graph and then the other big idea is that displacement is the area between velocity versus time graph and the horizontal axis. Okay? That's like big idea number one, big idea number two. That is this unit in a nutshell. Quiz tomorrow, so come ready for that. Question.
No. Okay, well, that's it out.
Okay, get to average speed, average velocity. I'm not quizzing on that this week.
Yeah, I'm just gonna.
Quiz test thing?
Yeah.
Okay. You good? What's up? What's up? You're pre-sick.
Yeah.
You did, yeah, you did the last page.
Yes.
Okay. So you're looking for displacement. Find the change of position of the velocity graph. Okay. Middle of the graph. Position versus time graph drawn based on figure out there. Here's the motion method. Starts here. Got my position kind of after that. Good. Yeah, so.
Is it Florida weekend this weekend or next weekend?
Next weekend. Homecoming.
See, I'm really pissed because I was going to visit my sister.